So, in continuation of atomic structure, so far what we have discussed was related to every nucleus or every atom contains nucleus, electron, and orbits. And so far, this nucleus was containing nucleons, they were neutrons and protons. Then we classified or we understood atomic number or nucleon number. Now we are on to what are isotopes. See, for example, uh, isotopes are atoms that have same protons but different neutrons. So, if we talk about isotopes, let's focus on these two given atoms. This is oxygen 16 and this is oxygen 18. Why do we call them as isotopes? Because they are the atoms of the same element, that is oxygen, but this contains 8 protons and this contains 8 protons. However, number of neutrons here are 8, but number of neutrons here are 10. So these are different in both the atoms, yet they belong to same element oxygen. That is why they are known as isotopes. Few isotopes, when we talk about our periodic table that we many times refer to in our chemistry, many elements of the periodic table, even it is right to say that almost every element in the periodic table has particular isotopes. And many isotopes of the given elements, they may be unstable. What does that mean? They are basically radioactive. Let's say if we talk about some isotopes such as hydrogen 1 1, hydrogen 1 2, hydrogen 1 3. These are basically three different isotopes of hydrogen. For example, if someone analyzes hydrogen in the atmosphere, it is more likely that he would find this dominant as compared to these two isotopes. Chances if we find hydrogen in the atmosphere of this nature, that means it would be having one proton and zero neutron, is 99% around. Chances that we find this is around 0.01, and chances we find this is around 4 exponent minus 15. That means very low chances. What does this supposed to mean? This means that majority of the hydrogen in our atmosphere and on our planet comprises of this isotope. It hardly comprises of these two. That means these two are very unstable. They emit certain radiations, they are radioactive, and they decay or they decompose to protium, that means this isotope, or any other element. What is electronic configuration? As previously understood that all atoms have two parts, nuclear part and some extra nuclear part. So if we are worrying about, if we are focusing on extra nuclear part, this extra nuclear part contains some orbits, and these orbits, they are basically filled up with electrons. So if we try to explain the arrangement of electrons in any atom, this process is known as electronic configuration. Each of the orbit around an atom comprises of different abilities or different places or different amount of electrons it can hold. Basically, in chemistry, we divide every atom or we divide every possible element into different atoms that can have 7 orbits, starting from the first, then second, third, up till seventh. First orbit or first shell is known as K shell, second is L, third is M, K, L, M, N, O, P, and last one is Q. So each of these orbits, whether K, L, M, has different capacity of holding electrons, such as K would be able to hold 2 electrons, L would be able to hold 8 electrons, and so on later on till Q shells. So in 5070 chemistry, we would be focusing on electronic configuration based on two rules, that is a duplet rule or an octet rule. Now, what does these two rules mean? But a duplet rule means that last shell of any element can have two electrons. This is more likely valid on hydrogen and lithium and helium. But when we talk about octet rule, this says that last shell of any element can have 8 electrons. That means last shell can hold up to 8 electrons, and this rule is valid for all the elements except these three elements. So this whole of the explanation basically can be referred to as electronic configuration. Let's say if we are discussing this lithium, so lithium has 3 electrons. These 3 electrons are arranged in a manner that K contains 2 electrons and L contain 1 electron. So this satisfies basically duplet rule, this satisfies octet rule. Although it may have 8 electrons, that means 7 electrons can be added. But the idea is, since I am having 3 electrons only, so L shall be having only 1 electron. If we are discussing this carbon, so carbon has basically 6 electrons. So out of these 6 electrons, K would be having 2 electrons, L would be having how much electrons? 4 electrons. So you can see this. This first shell is K shell, this would be L. For example, if we are considering any element that has, let's say, 10 electrons, let's consider this. Then K would be having 2 electrons, L would be having 8 electrons, and the structure would be something like this. 2 electrons, 1 and 2 in K shell, then in L shell 1, 2, 3, 4, 5, 6, 7, 8. That means this comprises of 10 electrons. Let's say if we are talking about any element that has 20 electrons, then K would be having 2 electrons, L would be having 8 electrons, M would be having 8 electrons, and then N would be having 2 electrons. That means we are only studying 8 electrons maximum in any shell. So this is 2 plus 8, 10 plus 8, 18 plus 2, 20. Okay. Now solving some question. Question belongs to November 2010, paper 2-1, part A2. The symbols of some atoms and ions, including their nucleon number and proton number, are shown. So this represents basically proton number. This represents nucleon number. That means it has the sum of protons and neutrons for every element. And this represents the charge. That shows that basically electrons and protons in these orbit in these elements are not in these atoms are not same. Whoever is charged, such as this and this, but these are neutral elements. That means whatever number of electrons are present in there inside the nucleus is equals to protons. However, these three elements, they contain more protons as compared to electrons. Had the charge been negative, for example Cl with a proton number of 17 and charge of -1 would be having extra electron, one more electron than protons. So which one of these atoms or ion has the greatest number of protons? So this greatest number of protons can be referred to as highest atomic number. So we can compare these and we can find this gallium, that is having 31 protons. Okay, which two of these atoms or ions have the same number of neutrons? So we are basically working for any two atoms that have same number of neutrons. So how can I work this thing out? Basically I need to calculate number of neutrons in each of them so that I may calculate which two if any are having same number of neutrons. So calcium, first case, is written 20 and 40 with a charge of +2. It has nothing to do with calculation of protons and neutrons. I can say clearly it has 20 protons, and protons plus neutrons equals 40. So neutrons comes out to be 20. Let's work this thing out for ferric, that is 26 and 58. So I can see clearly that it has 26 protons. Protons plus neutrons equals to 58. So neutrons would be 58 minus 26, that would be 32. Then coming towards gallium, it says gallium has 31 and 70. So protons are basically 31. Then protons plus neutrons equals 70. So neutrons would be 70 minus 31. It would be 39. Then it comes out to be manganese, that has a charge of plus 2. It says 25 and 55. So number of protons 25, number of neutrons would be uh, 55 minus 25. So I can say this is 0 and 30. Okay, then coming towards the nickel, it says 28 and 58. So if we are working with protons, they are 28. Protons plus neutrons equals 58. So neutrons would be 58 minus 28. So it would be 30. That means this 30 and this 30, they are same. That means I can refer to Mn and Ni as being two different nuclei that have same number of neutrons. So I can write manganese plus 2 with 25 and 55, and nickel 28 and 58 are the two atoms that have same number of neutrons. Number of electrons. So how can I calculate number of electrons? I already calculated number of protons. They were 25. So ideally speaking, electrons should be 25, but this is not the case here since it has a charge of plus 2. This plus 2 means it has two less electrons or two more protons. So how would I calculate electrons? That means if this charge had been 0, then this answer would have been correct. But since it is a plus 2 sign, then that means it has two less electrons. So ideally there would be 25, but now it has 23 electrons. Okay, write the full electronic configuration of calcium 20. So for writing the electronic configuration, you need to understand the number of electrons. So how many electrons it would have? If there is charge 0, then electrons and protons would be equal. But since but since this is carrying a charge of plus 2, so this is not the case. Then that means electrons would be 18. So how can I adjust electrons? I know K shell can have 2 electrons, L can have 8 electrons, M can also now have 8 electrons. So this is 2 plus 8, that is 10 plus 8, 18. It is winter 2011 question paper 2 question part 5. Bromine is a halogen. It has two naturally occurring isotopes. Okay, define the term isotopes. So isotopes has atoms of same element having same number of protons but different number of neutrons. Then it says one isotope has this symbol, state the number of protons, neutrons and electrons. Protons, neutrons and electron in this isotope. So proton is 35, neutron would be 81 minus 35. So it would be 6, 46. Electrons would be, since it is having no charge, so it would be equals to protons from the particles shown to answer these questions. Each particle can be used once, more than once, or not at all. This particle has only 20 protons. So proton would be calculated from the number of protons. So I need to work out where 20 is. So this has 20. So calcium has 20 protons. Which particle has a nucleon number of 35? Nucleon number means sum of protons and neutrons. So I need to see where it is written 35. Yes, here it is 35. So this is 35. Few students get confused in nucleons and neutrons. So you need to think this carefully. Nucleons means whatever is inside the nucleus. Which particle has an electronic structure of 288? So it is very easy to work out. 288 means you need to calculate number of electrons. 2 plus 8, 10 plus 8, 18. Then that means 18 electrons. I need to work out where 18 electrons would be. So this would not be having 18 electrons, 17 electrons, 17, 11, 11, 8. This would be having 8 protons. Just see this. It has 8 protons. Then ideally, if it had been no charged, then it should be having 8 electrons. But since it has a minus 2 charge, then that means it contains 2 more electrons. So this is 10 electrons. So this is also not my answer. Now let's consider this. It has 17 protons and it would be having 18 electrons. Why? Since this combination can give us a charge of minus 1. So I can write Cl 17 37 negative 1. Which particle is an atom with only 10 neutrons in its nucleus? So now it says magnesium chloride Mg plus 2 and Cl minus ions. Write the electronic configuration for a magnesium ion. Okay, so I need to take my help from the periodic table. Periodic table, in the periodic table, I need to see where is magnesium and what its charge number and mass number. So magnesium has a charge number of 12 and mass number of 24. So if I need to work out electronic configuration, I would be using this 12 as the number of protons. Had this been no neutral, then it should be ideally having electrons as 12. But since it has a charge of plus 2, then it means that it has 2 less electrons. So I can write it has 10 electrons. So now I can write the electronic configuration as K2 and L8. And it says the ion Q plus 2 has 3 complete shells of electrons. What is Q? So it has 3 complete shells of electrons. Then that means it has to be in the periodic table in the third row. So if we sketch this periodic table here, it's something like this, a general sketch. So first row, second row, third row. So what lies in the third row? It is calcium. You can see this in this periodic table. It would be somewhere here. Fine. Then the electronic configuration of 5 atoms are shown A, B, C, D, E. Which electronic configuration represents each of the following descriptions? Each electronic configuration may be used once, more than once, or not at all. A sodium atom. So if you need to work out a sodium atom, so you need to see the periodic table and you need to work out the atomic number and atomic masses. So it has 11 protons and it might have 11 electrons or it might have 10 electrons since it loses one electron to become stable. So let's see this is not sodium since it has 2 electrons. Let's count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This has 12 electrons, not sodium. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This appears to be sodium. So I can write C here. An atom with a proton atomic number of 12. So as I can't see any number of nucleons here for part 3. So basically I need to count the electrons and I need to believe that these electrons are equal to protons. So this part B basically has 12 protons since it has 12 electrons. So I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I can write B here. An atom of a noble gas which is used to fill balloons. So noble gases are those gases which have either 2 electrons in their outermost orbit or 8 electrons in their outermost orbit. And when it says that is used to fill balloon, it is only helium. So you can see this. It has 2 electrons and it is helium. So I can write A here. Then it says an atom which forms a noble gas electronic configuration when it gains 2 electrons. So now it says when it gains 2 electrons, then only it would be having a noble gas configuration, else it is not having any noble gas configuration. So let's see 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is not possible. 1, 2, 3, 4, 5. Let me check. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this has Total 8 electrons, 6 electrons in the outermost shell. So it is not a noble gas configuration, but this is the noble gas configuration. So I can write E here.